Hello students, welcome back to Akshar online IIT classes, and I am your chemistry faculty S. Mohan. Students, in the last class we were discussed about the synopsis 7, that is naming of chemical compounds, right? So previously in our main chapter, that is language of chemistry, so we are discussing about which chapter? Language of chemistry, and in that we discussed up to writing the chemical formula and naming the compounds, right? So that is the 7th synopsis, and 8th synopsis about the oxidation number, that we are not going to deal here. We have one more topic which is called stoichiometry and mole concepts. So there we are going to discuss about the oxidation number. So now I am not going to discuss about the synopsis 8. I am going to directly synopsis 9. So students, synopsis 9, and that is page number 70. Once you open your textbooks and just listen to me now, right? So today's our topic is chemical equations. Chemical equations. Before going to the what are chemical equations, already we discussed that formation of a compounds. Okay, we already discussed how to write the chemical formulas. For example, carbon dioxide formula you know, right? So carbon dioxide formula is CO2. Like this, many formulas you have practiced, right? But how this carbon dioxide is forming? When carbon burns in oxygen, then that's giving the carbon dioxide, right? When carbon burns in oxygen, then that gives a carbon dioxide, right? So this is called a chemical reaction. What it's called? A chemical reaction. So chemical reaction here, you might have studied about the physical change and chemical change, right? So physical changes are what? Where only there is a change in the physical properties and no new substances formed, right? And it's a temporary change. But chemical changes are what? Here a new substance is formed and a permanent change in the composition, change in the chemical properties, that's called chemical change. This chemical change is only considered as a chemical reaction. Okay. So now for example, if you see here just now I give an example, no? Like carbon burns, okay, in air to form carbon dioxide, right students? So this is a chemical reaction. Carbon is burning in oxygen and forming the carbon dioxide, right? So here this is a chemical reaction and we are writing this big sentence, right? Now this is chemical reaction. Then what is chemical equation is what? Representation of a chemical reaction, in short, by using symbols and formula. Okay, representation of a chemical reaction by using symbols and formula is called chemical equation. So students, here you know the carbon symbol is what? C, right? Here burns in, for that we are representing plus, okay, and air we are writing oxygen, formula is O2, already we discussed. To form we are giving arrow mark, carbon dioxide, you know the formula is carbon dioxide, okay. If it is gas, okay, this first we see this one. So here now this is a chemical reaction, this big sentence. This sentence, the same meaning we are written in the form of in a short term by using the symbols and formulas. How? C plus O2 gives rise to CO2. The carbon plus oxygen gives rise to CO2. Okay. So the same reaction we represented in short by using the symbols and formula. This is called the chemical equation, right? Now in the chemical reaction, students listen here, in the chemical reaction, which substances or which elements or which compounds are taking part? So they are called reactants. What they are called? Reactants. And what are the substances formed after the reaction? They are called a product. What they are called? Product. So here, what are reacting? Carbon is burning in air. Means what? Carbon is reacting with the oxygen, right? So hence, this carbon and oxygen are called reactants. What they are called? Reactants, right? Now, when this carbon and oxygen reacting with each other, then what is the new substance is forming here? Carbon dioxide, right? So this carbon dioxide is called a product. What it's called a product. So here the substances which are reacting, they are called as reactants, and the substance which forms a new substance which is formed after the chemical reaction, that's called a product, right? So here students, always reactant should be written in the left side in the chemical equation. So I said this is a chemical equation. So in this chemical equation, reactant should be written in the left side, okay, and product should be written in the right side. Okay, remember this is a very important part. So reactant should be written on the left side, and the product should be written on the right side, right? If reactants 2 or more are there, then we can join by using the plus symbol. Okay, if reactants 2 or more are there, then we can join with the symbol plus, right? And similarly, if the products are more, 2 or more, then here also we can join with the plus. Now, reactants and products are separated by arrow mark. They are separated by what? Arrow mark. Clear? So this is a chemical equation. So what's a chemical equation? Representation of a chemical reaction by, in short term, by using symbols and formulae is called a chemical equation. Is this clear to you? Any doubt till here? No. Chalo, once again briefly. So here chemical reaction means, here for example, carbon burns in air to form carbon dioxide. This is one chemical reaction. Okay, this chemical reaction we are writing in the form of sentences. Okay, and this we are writing now in short by using the symbols and formulas. This is called the chemical equation, right? And the substances which are taking part in the chemical reaction are called what? Reactants. And the substances which forms after the reaction are called products. If 2 or more reactants or if 2 or more products are there, we join with the symbol plus. And here, next what? These reactants and products are separated by the arrow mark. Clear to you? Chalo. So this is about the chemical equation, right? Chalo students. Now, this chemical equation, is it correct? Means absolutely correct. This one, this is absolutely correct. Now, I'll write one more equation. Okay, one more chemical reaction, and for that one more equation I'll write. So that is, for example, see students here, magnesium. Okay, magnesium. Again here also burnt. Okay, burns in oxygen to form magnesium oxide. Right? So this is another reaction. How the carbon is burning in air to form the carbon dioxide. Similarly, magnesium also burn in air to form the magnesium oxide. Now, how can you write the chemical equation for this? Now, see here, students, here, magnesium. So, what is the magnesium symbol? You know that magnesium is Mg, very good, plus oxygen, you know that oxygen is written as what? O2, okay? And magnesium oxide, you know that magnesium oxide, did you remember how did we practice? First we write the symbol of magnesium, otherwise I'll write here, symbol of magnesium we write, then we write the symbol of oxygen, and we write the valency of magnesium, that is +2, and oxygen is -2. If same numbers are there, we can cancel, so then it becomes what? Magnesium oxide MgO. Chalo. So magnesium oxide formula is MgO. Right? Magnesium oxide. So now here magnesium, this we are written this chemical reaction. Okay, instead of writing this big reaction in the form of sentences, in short we have written by using the symbols and formulas. So magnesium symbol is Mg, oxygen is O2, and magnesium oxide is MgO. Right? Now see here, magnesium symbol Mg correct? Yes. Oxygen formula is O2 correct? Yes. Magnesium oxide formula is correct? Yes. Everything is correct. But if you write this as it is in your examination, then your teacher may not give the marks to you. Okay, the teacher cannot give the marks to you here if you write this equation for this chemical reaction. Now the question arises, why? Sir, I have written correct only. Magnesium symbol is Mg, Oxygen formula is O2, magnesium oxide formula is MgO. According to crisscross method what we practice, then why the teacher cannot give the marks to me? So students, here you see here there is one law is there, okay? That law is called law of conservation of mass. What is called? Law of conservation of mass. According to this law of conservation of mass, the total mass of the reactants, should be equal to total mass of the product. Okay, how much mass of the reactants you are taking after the reaction, the product's mass also should be same. They should both should be equal. So according to law of conservation of mass, what it says is mass can neither be created nor destroyed. Mass can neither be created nor destroyed during chemical reaction. During chemical reaction means what? How much mass of reactants you can take, the same mass of the product also should be. Clear? Okay. But here we don't know the mass. So instead of that, what we do? We take the number of atoms. Okay. So how many number of elements, how many number of atoms of elements or compounds present in the reactant side? The same number of atoms of elements and compounds should be present in the product side. Okay. So how many elements are we are writing in the left side? The same number of atoms should be present in the right side also, product side. Now let us see here how many magnesiums are there here. Only one magnesium is there. Okay, very good. Now here how many magnesiums are there? Only magnesium, one. Very good. But see now how many oxygens are there here? Two oxygens. But here how many oxygens are there? Only one. Okay, then where the one oxygen is gone? According to law of conservation of mass, what? Mass can neither be created nor destroyed during the chemical reaction. And the total number of atoms of elements or compounds, the reactant should be equal to product. Okay, but they are not same. Then what happened to that oxygen? Right? So that's the reason this equation is wrong and your teacher may not give the marks to you. Clear to you? Chalo. Now then what can I do? Okay, so here this reaction, what the chemical reaction is there? So that as it is what you are writing the chemical equation, then this equation is called skeletal equation. What is called, students, here? Skeletal. Okay, skeletal equation. So skeletal equation, what you are doing? Magnesium symbol Mg, oxygen formula O2, magnesium oxide MgO. You written correct only, but it's not balanced. It's not obeying the law of conservation of mass. It's not obeying the law of conservation of mass, right? So this equation is called a skeletal equation. So now this skeletal equation should be balanced. Balanced means what? On both the sides the number of atoms should be same. So for that purpose what we need to do is, so here see students, here what we need to do, here magnesium, here one magnesium, okay, two oxygens is there. Can we write it to here? No, you should not write, because magnesium oxide formula according to crisscross method is what? MgO only. Okay, you should not write here 2. Okay, then what we need to do? We need to write, okay, so to balance it, we need to write the number in front of the compound as a coefficient. In the mathematics, you study coefficient. Okay, so here like that. So here one magnesium, but here two oxygens. Here only one oxygen is there. So that's what you do. Write 2 in front of this magnesium oxide. So here I'll writing here Mg plus O2. Here MgO is but what I'm doing is I'm writing 2 here. I'm writing there what? 2. So why? Because there are 2 oxygens are there. So I want 2 oxygens should be there. So that's what I'm writing 2 here. I should not write here 2. Okay, you should write always in front of this one only. So writing 2. Clear to you? So now, okay, now 2 oxygens, 2 oxygens, balanced. But if you see the magnesium, here one magnesium is there, we kept 2 in front of magnesium oxide. So this belongs to this 2 means that magnesiums are also 2, right? So I have to balance here 2 magnesiums are there, but here only 1 is there. So in the next step, what you do, Mg plus O2 gives rise to 2 MgO, is there no? So here 2 oxygens balance, but here 2 magnesiums, so there only 1 magnesium. So write it 2 here. That's all. Okay. Now this equation is said to be balanced. That equation is said to be balanced. Why? So the total number of atoms towards the left side and the right side same. So 2 magnesium atoms and 2 magnesium atoms, 2 oxygen atoms, 2 oxygen atoms. So both sides the is number of atoms are same. Now this is obeying the law of conservation of mass. Clear? So this is a correct chemical equation. If you write in the examination this one, then your teacher give the full marks to you. Clear to you? Your teacher give full marks to this equation, but not this equation. Okay? Because this is a skeletal equation. Skeletal equation, it's not balanced. Okay? But here it is balanced. Total number of atoms in the reactant side is equal to total number of atoms in the product side. So, according to law of conservation of mass, water mass can neither be created nor destroyed. This is, did you understand now? So, this is the writing of chemical equation. Clear? Ciao. Now, see students, what are the advantages of this chemical equation? So, students, here chemical equation advantage is that, here see here, advantage is that we are writing in short. Instead of writing this big sentence, we are writing in short. So, in simple way, easily we are writing. That's the first thing. Okay. Second thing, one of the most important thing is that carbon burns in air to form carbon dioxide. This is a chemical reaction. But how much carbon is burning in how much air? Okay. So, how many atoms of carbon requires how many atoms of oxygen to form carbon dioxide? This information we don't have. Okay. A magnesium burns in oxygen to form magnesium oxide, that we know. But how much magnesium is required? Okay. How much magnesium burns in how much oxygen to form magnesium oxide? Right. So, for example, you see, you are making a coffee. For example, let's imagine you want to make a coffee. So, to make a coffee, what we need? We need some milk, we need. Okay. And we need some sugar, we need. And we need some coffee powder, we need. Right. So, here, if you make a coffee tasty, then what we need to do? You take just cup of milk. Example I am telling, I am not a coffee expert, but okay. Okay. So, here, if you want to make a coffee, you take 1 cup of milk. In that you take 1.5, okay, 1.5 cup of sugar, and then what is it? Okay, once again see here, take 1 cup of milk and boil it, and in that add 1.5 spoon of sugar, okay, and 1 spoon of coffee powder. So, if you mix, then you get the coffee. Okay, this is the quantities actually. Okay, if I want to make a coffee, right? Now, for example, you don't know how to make a coffee. For example, okay, you don't know how to make a coffee. Okay, I say that take the milk, take the coffee powder, take the sugar, and mix. Then you get the coffee. Then, if you do like that, if you take 1 cup of milk and 1 cup of sugar, 1 cup of tea powder, can you mix it? It will not be tasty here. Yes or no? It will not be tasty and no one can drink. In 1 cup of milk, if you add 1 cup of coffee powder, then how much it becomes? It's become very bitter. Okay, so no one can drink. Means there should be some quantity is required. Yes or no? So here also, here carbon burns in air to form a carbon dioxide. Okay, means what? Milk, coffee powder, sugar. If you mix, you will get a coffee. That much information is there. But how much milk, how much coffee powder, how much sugar? That information is this chemical reaction does not give. So that if you see here, this balanced chemical equation can give that information, right? So 2 magnesiums react with 2 oxygen to form the 2 molecules of magnesium oxide. Clear? So that is about the advantage, right? Now here some disadvantage also there, students. Disadvantage is what? Here magnesium burns in air to form the magnesium oxide, we know that. But what is magnesium? Whether it is solid, liquid or gas, we don't know. What is oxygen? Whether it is solid, liquid or gas, we don't know. What is magnesium oxide? This is a solid, liquid or gas, we don't know. Okay. So this information will not be given by just by writing this equation. Okay. So you have to make the this equation more informative. You have to mention the physical states. You have to mention the physical states. Like magnesium is what? A solid. So write S here at down at the bottom as a subscript. Oxygen. Oxygen means what? So it's a gas, right? So you write G here, gas. And magnesium oxide is again solid, so I'm writing solid. So now we get like information. Clear to you? So like this, okay, we make the chemical equations more informative. Okay, so this is about the chemical equations. Any doubts, students here? Yes? Chalo. Now what we do is, let's practice just 2 or 3 examples how to balance the equation. Okay. So this you understood now? Till here, no doubt? Okay, I am rubbing this one. So students, now I'm going to write some, okay, 3 chemical reactions, and I'm going to explain you how to balance them. Then you need to practice. Okay, you need to practice. So for example, first one I'll write like, can you see here? Yes. So you can see a first one example extra. So nitrogen react with oxygen, to form, okay, to form ammonia, to form what? Ammonia. Okay, so this is one chemical reaction. Okay, now this chemical reaction we have to convert into chemical equation. Okay, so already we discussed that nitrogen is a diatomic molecule. What it is? Diatomic molecule. So that is N2. We can write as what? N2. Right? Now react with means what? We write plus. Oxygen. React with what? Oxygen. Oxygen is also diatomic. So that is O2. Sorry. Here just sorry. Nitrogen react with the hydrogen student here. Okay. So hydrogen. Okay. So here this is hydrogen. So hydrogen means what? H2. Okay. H2 reacting with what? H2 and gives ammonia. You know the formula of ammonia already we discussed, that is NH3. Okay. Now we are writing like so here chemical reaction is what? Nitrogen react with hydrogen to form ammonia. Right? And a nitrogen formula is N2 react with this plus we are writing hydrogen is H2 to form arrow mark and ammonia is NH3. Clear? Now this according to this one, this is correct only. Okay, but elements are correct, balanced or not, let's check. According to of conservation of mass, what I said, the total number of atoms in the reactant should be equal to product side. Now once you check here, 2 nitrogens, but here only 1 nitrogen, here 2 hydrogens, but here 3 hydrogens are there, it's not balanced. It's not balanced. So now what we need to do? We need to balance. So this reaction is called the skeletal equation. Skeletal equation. Okay. Now what we need to do is you have to balance. So here how many nitrogens are there? 2. Here how many nitrogens are there? Only 1. So now what we do? See now students, N2 plus H2 gives rise to NH3 is there. No. So here 2 are there, only 1 is there. Can I write 2 here? No, you should not write 2 because ammonia formula is NH3 only. You should not change. Then where you need to write the 2, you have to write in front of this one. Here 2 nitrogens are there, but only 1. So write the 2 in front of this one. 2. Right? Now, so okay, now 2 nitrogens balanced. Now here how many hydrogens are there? 2. But here how many hydrogens are there? 2 into 3. 2 3s are 6 hydrogens are there. How many hydrogens are there? 6 hydrogens are there. Right? Now I have to balance the hydrogen. So for that what we need to do is N2 plus 3 H2 gives rise to 2NH3. So here how many hydrogens are there? 2 3s are 6. But only 2 is there. So I should multiply with the 3 here now. So N2 plus 3H2 gives rise to 2NH3. So here 2 nitrogens, 3 2s are 6 hydrogens, 2 3s are 6 hydrogens. So balance now. This is called a balanced equation. Clear to you? Is this clear? Okay. So this is about the balancing of nitrogen. even react with the hydrogen to form the ammonia. Understood now? Chalo, one more example I'll explain you, and with this we'll stop now. Okay, one more example what I explain is, okay, what do we take? One more example what we take is, okay, simple one. Take hydrogen react with oxygen to form water. Achha. Here one more step we forgot now. So we have make to more informative. The reaction should be more informative. So what I said, you should mention the physical states. Okay. So physical state of nitrogen is what? Gas. So write here gas. Hydrogen is also gas, and ammonia is also gas. Okay. This is right. Now here you can see hydrogen react with oxygen to form water. Okay. So here how can you do? Hydrogen already you know we written here H2. So write H2 and react with means water plus oxygen is O2, and you know the water formula. Water formula is what? H2O. Whether it is balanced? No, because two hydrogens okay, but here two oxygens are there, only one oxygen is there, right? So now what we need to do in the second step, you balance the oxygen. Two are there, only one is there. Okay. So write here H2 plus O2 gives rise to H2O is there, right? So two oxygens but only one. Okay. So for that what you need to do, you have to write the 2 in front of this one. So now two oxygens balanced. But see the hydrogens are changed now. Here 2 2s are hydrogens, 4 hydrogens are there, 2 2s are 4, but here only 2 hydrogens are there, right? So H2 plus O2 gives rise to 2H2O. Okay, here 2 2s are 4 hydrogens are there, but here only 2 hydrogens are there. So you write it 2 here. You write here 2. Now check now. 2 2s are 4 hydrogens, 2 2s are 4 hydrogen balanced, 2 oxygens balanced. So this is balanced equation. But make it to more informative, what you need to do? You need to write their physical states. So hydrogen is what? Gas. Oxygen is what? Gas. They are actually water vapor forms. So we can write here also a gas. And if later it on cooling, it converted to liquid also. Okay, you can write liquid also, no problem. Is this clear to you? So students, in this way, okay, we write the chemical equations. Right? Chalo, last and final time when I just once again explain you. So chemical reaction can be represented in short by using the symbols and formulae is called a chemical equation. Okay. So chemical equations should be balanced equation. You should write always. Okay. According to law of conservation of mass, mass can neither be created nor destroyed during the chemical reactions. Okay. This is what the total number of atoms in the reactant side should be equal to product side. Okay. And the elements or the compounds which are participating in the chemical reaction, they are called as the reactants. And what is formed after the reaction, new substance, that is called as a product. Reactant should be written on the left side, product should be written on the right side. If the reactants or products are more than 2, then we should add a plus symbol them. Okay. And to make more informative the chemical reaction, you should better to mention the physical state, whether it is a gas or liquid or solid, whatever it may be, you have to mention that. Clear, students? So, with the students, we completed this topic, synopsis 9, and okay, we practice some more chemical equations. We practice, okay, keep on practice so that, right? Okay, so until we stop today now the class, and you take care of yourself, right? And study well, do your work well, and be a good student, right? Thank you.